Great. So, just wanted to say welcome to everybody to Computer Science 3060U. This is software quality assurance. It's a course that I've actually taught. Well, put it this way: I've taught it for many years. I was actually the one who designed the original course here, and before I taught this course here, I actually taught a version of it as a graduate student when I was doing my PhD at Queen's University back in 2005. That was the first time I ever taught this. So this is a topic I know fairly well. It's something I'm passionate about and interested in. Although I do recognize that, when people hear software quality or quality assurance, you can kind of think, oh, this isn't going to be the most exciting thing, right? Like this doesn't, augmented reality, user interfaces, 3D graphics, mobile device development, like those things sound a lot more interesting, machine learning. So like I recognize that some aspects of this might be not as engaging as others, but I'll do my best to try to make it interesting for you by mixing in some of the latest things that are being done in industry and using some case studies in that. And I'll talk about that a little bit. So anyway, hopefully we'll have a good time. You'll get to learn something. The one positive I can say about the course is that I've gotten a lot of feedback from students over the years. And the one thing that I've consistently gotten from students about this course is, especially for students who go and do co-op, for example, after taking the course, a lot of them have told me that what they learned in this course was really useful for when they actually went and worked in industry, whether it's co-op, their first job, and that. So I've actually gotten a lot of students come back and say that to me, which is a really nice thing to hear because one of the goals is to teach you, but it's also to teach you things that are relevant, right? It's not just teaching for the sake of teaching, but teaching you topics that actually give you and enhance your knowledge, and also that you can use and apply in your life after school. So that's something that I have heard, and I hope that's also the experience for all of you. If I've met you before, that's awesome. If I haven't, welcome. I wish I was meeting you in person, but obviously that's not the case. For those of you who've never met me before, my name is, I'm Dr. Jeremy Bradbury. Oop. Sorry, that was my bad. And I've been at Ontario Tech since I joined in 2007 at my PhD, originally from Newfoundland. And yeah, just don't really know what else to say. Oh, I have a dual role right now. I'm also the associate dean of over in the School of Graduate and Postdoctoral Studies. So if you have any interest in grad school in the future, whether it's working in a research capacity with me in my lab, or it's just finding more about what grad studies involves and getting some advice, happy to talk to people about the grad studies, and I can connect you with the relevant people to help you based on your interests. So just a little bit about me, and yeah, looking forward to getting to know all of you. We've got two TAs for this course, Stacy Corneef and Hamoon Jafarian. I am meeting with the TAs this week, so I can give you more details. Stacy, I know. She's a master's student who's working with me. She also has taken this class. She's done an internship while an undergrad here as well. Brings a lot of experience. Hamoon, I haven't met yet, but I'm sure he also is going to do a great job. And once I meet with them, I'll have more details on which laboratory sections they're covering and so on. Right now, we have 2 lectures for the course, today and Thursday, 3:40 to 5 p.m. These are online. The labs are also listed here. Each lab is an hour and a half. Those are also online through Google Meet links as well. The labs aren't starting this week. They will likely start next week or possibly the week after, depending on how things go with the TAs and that. So please stay tuned, and I'll give you more details about the labs. I'll make an announcement about that actually on Thursday, so you know in advance. And as I mentioned before, if you have any questions as I'm going through this stuff, post a chat message, raise your hand, turn on your mic. What I'm going through right now is basically the course outline details, and then I'm going to give you a brief introduction to the course, and that'll be what we'll cover today. Okay, what textbook do we use in this course? We don't. There's no book that I feel really covers all of this in detail or to the level that I want, what I cover in the course. So instead, what I'm going to be using is a combination of online resources and open educational resources. These will all be listed on the website. Because there's no book, I'm making an effort to have more detail in the slides. That doesn't mean that I'm going to cover all the detail in the slides. It just means that there will be a little bit more there. So in some cases, I may say, hey, I've put in an extra couple slides on this. You should read through this and know it, but it's not something we'll actually discuss in class. But if you have questions, you can bring them up the next time. So that's how I'm going to try to do it. Provide you with those types of materials and that. Some of the things I'll also be providing you with is some video content and stuff as well. And some of that we'll discuss in class. Some of it, if it's a little longer, it will be something I'd ask you to do outside of class. So that's the book. In terms of what the aims are for the course, really, this is a course that's meant to build on what you've already learned about software engineering in previous courses, primarily the 2040 course, right? The software design and analysis course. And the idea here is that we're actually going to focus on something. So a lot of what you did, and I don't think I taught you programming workshop, because I normally teach that course, but I think the year you were in your first year, I believe I was actually on a research leave, or parental leave maybe, yeah. So I didn't teach you that, but in that course, like I encourage students in that course, when you're starting out programming, it's really to get it working, right? Can you figure out a solution that works? But as you become more proficient in programming and software development, the aim is no longer, thank you for that, Joshua. And the aim for that is no longer to just create software. It's actually to create high quality software. So how do we make software that's really good? Not just software that works or does what it's supposed to, but maybe flakes out half the time or crashes or has a few bugs or incomplete stuff. So the aim in this course is to take what you've done and your development and abilities and take it to the next level and move from being able to build software to build high quality software. And we're going to learn about this. We're going to learn about a lot of the relevant practices that companies use, that industry uses, that you're expected to use if you go work for a company. And we're also going to try to take some of what we learn in the class and apply it in a group project. And I'm not going to lie, the group project will be a fair bit of work. But the benefit of the group, but because of that, I'm actually going to cut out, I'm not going to have a final exam. And we're going to really sort of make sure that you understand, while it is a lot of work to do the project, there are going to be less constraints on your time with some of the other deliverables. So I'll talk about that in a second. So this is sort of, this is sort of some of the typical topics we cover. I'm still working this. So in the official course outline, I haven't listed all of this in detail. I just want to give you an example of what the flow was last year. I'm constantly sort of evolving this course and updating it. I stopped teaching it for about 3 years, and it was taught by sessional instructors. And I last year started to revise it and update it because I realized some of it was out of date. So what I'm going to be doing basically today is giving you this intro. What is software engineering? What's software quality? Then I'm going to talk about software development process. But really, you can think about it as development practice. I'm going to talk about how do we actually achieve software engineer or software quality in industry? And I'm going to emphasize on agile development with a specific focus on looking at some companies and how they do things uniquely versus other companies. So we're going to spend a week on that software process. We're going to actually spend 4 weeks on software testing. And that's because testing, while not the only thing that actually produces quality, it's probably the technique related to quality that you've had the least exposure to up to this point, right? Being able to design good software, being able to program software correctly, gather requirements, all those things ensure quality. But you've often seen some of that in your other courses. testing is something that you've seen a lot less of in your other courses, and therefore I'm going to spend a full month basically on testing. And we're going to cover a whole bunch of different practical testing things as well as test automation. And because there's actually some companies, one of the things they really talk about with testing, which is really interesting. And I know a friend of mine who actually a former, I guess a former student that I was in grad school with, he told me that like one of the things that's really interesting where he works, and this is a major software company, is their best programmers are actually in the testing group, because the testing group, they do very little manual testing. Everything they do is actually automated. So what they're interested in doing with the automation is they actually are building the software that makes sure the other software works. So in some ways, the programming challenges for the testers are actually greater than the programming challenges for some of the developers, depending on the system they're working on, which is a really interesting thing to learn about. We're also going to talk about something called software inspection and code walkthroughs. And this is really something it's useful to know. And it sort of leads to something else we'll do, which is automatic techniques for analyzing code. So when you're actually making sure a program works or software works, one way is to try it. It's to test it. You run the software and see if it works. Another way is to actually analyze, review it without running it. And so in software inspection, the emphasis is on the actual software artifact itself. So like the source code, the design specification or whatever, and you review it and see if it makes sense. And often you can find different kinds of bugs, for example, in the case of code, by reading through the code and seeing it than you can by running it. Okay, so we're going to learn about those different types of bugs you can find and why these are complementary techniques and useful. Another thing we're going to spend time on is dynamic analysis. This is other types of analysis techniques that require executing the code but are slightly different than software testing. We're also going to be spending some time on static analysis, which are automatic techniques for analyzing the source code without running, or other artifacts without running it. And lastly, we're going to also spend some time on software metrics because measurement is something that's really useful. And when it comes to quality, one of the things you have to do is it's really important to understand when you're talking about software quality to know how well you're doing, right? If you're using techniques and you can't tell, are they working? Are they helping? Is my software actually better? You need to actually have metrics to actually be able to tell that, hey, you know what? I have 3 fewer bugs per 1,000 lines of code than I did a month ago since I started using technique X. Like, that stuff is useful. So I see a question here, which I'm going to comment on, and it says, isn't it usually the case that it's easier to spot bugs in code that you haven't been involved in compared with finding bugs in your own code? Because whatever blind spots you had writing the code, you also have when reading it. So this is related specifically back to that idea that we talked about in the last slide, which is code software inspections. So best practice when you're doing an inspection is to actually have somebody else inspect the code. And there is a certain bias you have to watch for. And an analogy, Cody, that I'd use in this case is something similar to like when you actually write a paper and you read it. Sometimes when you're writing it, you're so close to the topic that you make assumptions that bias you. So you may make assumptions about how the code works, how the inputs, what type of input you're getting, and you may forget about stuff just simply because you're too close to it. And this holds true for whether it's English prose, if you're talking about a paper, or if you're talking about source code and other things. So there is definitely a benefit in having a third party or somebody whose arm's length review the code. That doesn't mean you can't find benefit in inspecting your own code. It just means that the benefit you get may be slightly different by having somebody else do it, or slightly enhanced by having somebody else do it. But that's a great question. I appreciate it. So the other thing that I want to really include in the course, and I started doing this last year, and I'm going to be putting even more in this year, is I'm going to try to have a few guest speakers come in from industry to talk about what they do. And I'm also going to be introducing some case studies. And these are going to be basically examples of software quality practices that are used by companies to improve the software, to find real bugs, and so on. And here's 4 examples of things that are definitely going to be in the course. Last year, I sort of set this out as a goal, and I was able to get 2 of the 4 in detail, and 1 in partially. And this year, I'm going to add the others in. So these will be in, plus hopefully a bit more. One of the things I want to talk about is something called chaos engineering. Has anyone ever heard of this? Okay, so chaos engineering is a practice that's used at Netflix, and it's something that they use to test their systems. And it actually involves this idea of introducing a failure, for example, like let's have a server fail live and see how the system handles it. So like testing in production in some ways. And they do this to keep the developers on their toes and to keep them always thinking about robustness, and making sure that the system can actually manage and recover quickly from failure of hardware and so on. So thinking about redundancy and so on. So they use this principle, this practice called chaos engineering, and we're going to be spending some time in one of the lectures actually going through some examples of this, and we'll talk about how it might be able to be applicable in other places. Another thing we're going to talk about is software testing at IBM. And specifically, there's a couple of people who I'm not sure which one I'll actually be able to get in. But one of the people I want to talk to at IBM, I'm interested because IBM is a huge company that does a lot of large-scale software, enterprise software specifically. And one of the things they actually also do is they do a lot of consulting work, and they have a lot of customers. And something that they're really good at is testing infrastructure. So, for example, when you have a large system with a lot of tests, there's one group at IBM and that I'm hoping to bring somebody in from, who what they've done is they've built this whole parallel infrastructure, which allows them to test the system by running multiple tests in parallel simultaneously, so they can test faster by doing it in parallel. And it's a great example of how infrastructure at the really top companies is really allowing them to drive, I guess, their innovation, because the bottlenecks that you might encounter as a smaller company, that they can bypass them or overcome them through large scale parallelism, and through essentially a lot of it is brute force in some cases. But so I'd like to talk to somebody at IBM in the class about that testing infrastructure. Another thing that I'm going to try to bring somebody in is to talk about quality assurance in next generation systems, including autonomous vehicles, robotics, that kind of thing. I actually have experience in this myself. And I've been working, I'm just at the end of a 3-year project on where we're actually doing cybersecurity testing of autonomous vehicles. And that's been a really cool project. And I'm going to be able to hopefully share some of that with you by also bringing in one of our industry partners to talk about the project and sort of some of the things that we set out to do and some of the best practices for quality assurance in autonomous vehicles. The last example I have here that is I covered last year, I'll cover again, is looking at, you guys all know Spotify, right? Yes. Okay. So Spotify actually has this really interesting engineering culture in terms of their development. And I'm going to actually be using it as a case study when we start next week, or on Thursday, talking about process and agile practices. So we're going to cover Spotify's engineering culture in the class because it's a really interesting idea and you can see how they've taken concepts that like show up in textbooks and stuff and adapted them to fit the culture and meld with the culture of their own organization. So what they've done is they've taken a practice, and rather than using it straight out of the book, a process, they've actually tweaked it, adjusted it so it fits with the way they develop. And what they've ended up with is sort of this modified version that achieves the original goals of a lot of the agile methods, while also satisfying the needs of the employees that they have. And it's a good example, I think, of engineering culture and practice, and how it can be, how having the right culture, the right process, the right practices can improve software quality. So that's another example of a case study. Does that sound interesting to you guys to cover some of those things, or would you prefer? I just want to stop here just to see. Does that, any questions? It could be cool, maybe. Okay. Let's do it. Sounds interesting. Coolio. Okay. So sounds like nobody's. I've only had like 2 people leave the class so far, so that's awesome. So moving on. So that's a little bit about what we're going to cover topic-wise. In terms of the marking, this is something I want to make sure it's clear with you. So what I'm going to be doing here is I'm going to actually, in the past, before the pandemic, I used to also have an exam in here. But what I've realized is that the course project is a group-based project. And doing the group project remotely is hard. It's not as easy as when you can get together in person. And recognizing that, I don't want to create a situation where you have too much stress, too much work. So what I've done is I've decided to cut out the final exam so that you have more time for the other things. So what we're basically looking at is 50% is going to be your course project. I'm going to give you a 40% of your mark for 3 term tests. Those are already listed date-wise in the Google course calendar, as well as in the course outline. The first one, I believe, is the Thursday before reading week. The second one is mid-March, and the third one is the last Thursday of classes in April. And so each of those tests is basically going to cover 1/3 of the course. They're not cumulative, so the test 2 only covers the second third of the course. Test 3 covers the last third. And each test will be one we'll do in class, and that's it. So once I test you on the first third of the course, I'm not testing you again beyond what you have to apply in the course project. And there's also going to be a 10% participation mark. And that's something we'll also be utilizing as well. And that's to encourage students to attend lectures. So I'm going to be keeping track of attendance. I'm not doing it for today because I didn't announce it beforehand. But starting Thursday, I will. If you miss or you can't attend for whatever reason, that's okay. I'm not going to get full marks for participation. The attendance is not going to be based on attending 100% of the lectures. I'm going to set a threshold of like 85% or something like that. And that'll be so participation as well as contributing through the chat and so on in class. Somebody just asked about, so the tests are basically equally weighted 40% of the grade. So it works out to be 13.3, which isn't very nice, but it doesn't really matter. It's just, that's what it is. So, and the last thing I want to mention as well is that I also noticed, and something I've noticed, this happens before as well, before the pandemic, but since the pandemic, it's way easier for people to like, I know this isn't usually used in course context, or maybe it is, like, the term like ghost somebody. Like, I feel like that happens a lot more in the course project with group mates when it's virtual than when it's in person. Like when you have a group and you're like, okay, we're going to meet, in the UB CAF at 6 p.m. Like, people show up. When you're like, we're going to meet in a Google Meet at 6 p.m., people like just don't go. And I've heard more and more stories from students that they've had issues with a particular group member or whatnot who just doesn't come, doesn't contribute, and then that's not fair because it's a course project worth 50%. So what I'm including this year is a peer evaluation of team members. So every time you submit a phase of the project, and each project, the project is basically 5 to 6 phases, 1 to 2 weeks each. You'll have time in the labs, which guarantees you have time to work with the other group mates who are also in your lab section. And every time you submit, every group member will also be required to submit a form where they basically evaluate how much work they did, estimate how much work the others did, and identify any problems. And this will allow me to kind of keep track of things, and if needed, I can actually help students. However, if it does actually continue and I see this, it'll actually it can contribute to your final mark. So I sort of reserve the right that if a group member really, everybody else is, this, if the group member hasn't been contributing at all for the whole project, they aren't going to get the marks just simply because their group members did all the work. So that's just something to keep in mind. And the phased idea, just so you know, I see somebody said here, that's so you actually have deliverables, because I know what happens. You get busy and everybody pushes things to the end of the semester. So the idea is that you can't do that. And then there's also going to be a couple little surprises in the project that'll be fun, which will help to try to simulate at least experiences you might encounter in the real world. And in general, those have been well received in past years, and I'll try to continue to do some of those things. I mix it up from year to year, so I don't always do the exact same thing every year. Project groups pre-made, how big should they be? I'm going to get to the project in a second, but I might as well just say it now. So projects are probably going to be 3 to 4 people in a group. You're going to pick, there will likely be, you'll get to pick your groups, but it's going to be done in the lab time. So there will be the very first lab, there will be an activity for group picking. So and it's I haven't exactly decided how that's going to work yet, but I'll keep you posted. I'll give you a heads up on Thursday so everybody knows at the same time. Okay. So a couple other quick, like, small things. Course website. So I typically like, I actually think Canvas is pretty good. Like, Canvas I think is better than the LMS, the learning management software we used to have. But I'm still a little wary of it because like, if I put everything in it and it goes down, well, if you can't log in, you can't access it, right? But if I actually keep things outside, like if my website goes down, I can just post it on another website and you can access it easily and so on. So I find in general, I like the idea of just posting the notes and stuff out on the course website. So this is the URL for the website. It's listed from Canvas. So I won't be posting my lectures in Canvas. I minimally will be using Canvas. Canvas will mainly be used for grading of things. It'll be used for online tests, and it'll be used for submission of phases of the project. The course website will be used, the course outline is there, the lectures will all be listed there, lab details will be listed there. There is a Google Calendar on there. That is a public calendar that you can actually import and add to your own schedule. So that way, and it includes not just sort of when the lectures are with the Google Meet links, but it also includes the dates, the due dates for different phases of the project, as well as the dates for tests and so on. And there's also a list of resources that are useful, and I'll add to those resources throughout the course. If you want to get extra marks for your participation, you can always share with me resource links you think I should be adding to that page. And you can either do that through contact me directly or through the comments section of the resources page. We're also going to be using Slack for communication. Slack is something that I think is useful. I know some of you may like to use Discord better and whatnot, and I've had this discussion with students. Do people prefer Discord or Slack? Just curious. I see one Slack followed by 10 Discords and then a Slack. Okay, there's a Slack for school. Yeah, go ahead. Everything. So when I'm talking about Slack, I'm talking about using Slack for discussions, Q&A, course announcements, contacting your professor or TA, doing private group chats with your group for the project, whatever. So here's the reason that I use Slack, and a couple people are hitting it. It's a professional platform, right, which is mentioned. There's also a lot better tie-ins for some of the professional development tools. And one of the things that I want to do is, while some places, Discord originally is more of a gaming chat platform, right? It's not, Slack started as like a platform actually for essentially tech business. And it's used a fair bit, or similar platforms are used. So I want to give you experience with Slack in order to so Slack is something I want to give you experience using, since it's likely you will need to use it at some point in the future. Somebody just asked, so the Slack for the course, you can't sign in right now because I haven't set it up yet. So what I've done is I have it there ready, but I need to send you invites. So all of you will be getting an invite to your .NET emails, which are the emails that are associated with your Canvas. So you should be getting an invite between now. It won't be today, but it'll probably be tomorrow. Look for an invite for Slack. If for some reason you don't get an invite, you can let me know on Thursday and I'll send you something. So Slack is what we're using for a lot of stuff for communication. Yep. I haven't tried connecting it with Clubhouse, but there are the API is fairly well utilized, and there's a fairly rich set of plugins. So you can connect it to other social media platforms such as Twitter. You can also connect it to project management software, so Trello, those kinds of things. You can also connect it to things like GitHub. Yeah. The participation, yeah. I mean, if you're participating through Slack or through the in-call Google Meet or whatever, that all goes towards participation. And I want to be flexible at that, because I understand not everybody wants to participate in the same way. Not everybody's comfortable actually raising their hand and speaking in class, right? So I want to give different avenues for participation so that you can actually find the way to participate that is most comfortable to you. That's not to say that I don't encourage people to push beyond their norms and try to. Sometimes doing something uncomfortable in terms of participating in stuff can help you to sort of expand and grow a little bit, but that's something you should decide, not something I should force on you. Okay. Last thing is the course project, which I already outlined this, so I'll basically skip it. 5 to 6 phases, 1 to 2 weeks in length. Each phase has a deliverable. So at the end of each phase, you deliver that phase. And then the next phase builds off that phase. Okay? And there will be more details on the project coming. But for now, that's all you really need to know. So that's a little bit of the overview of what the course involves. If there are questions, I can answer them. I do have a few slides that I want to cover now, just as a little intro to software quality before we actually break for today. Any questions about the outline of the course? Okay. Seeing none, let's just jump into the actual course content. This is a little bit dry, but I'll just cover it. So in general, software engineering, you're in a computer science program, everybody in this class. Although software engineering is something that's very relevant, and there's a huge overlap between software engineering and computer science. And whether you're a software engineer or computer scientist, software development for a lot of you will be one of the primary parts of your job after, or at least at some point in your career. And in general, you can think about that software development or software engineering as being the application of a systematic, disciplined, quantifiable approach to development, operation, maintenance of software. There's two things that I actually think are really important in this. Does anyone want to guess? I was saying there are two things in this definition I think are really important that you don't always think about. The first one is this maintenance and operation here. Normally some people think about software engineering, software development as only being about the development of software. Once I build it, it's developed, it's engineered. But high quality software, you actually have to develop it throughout the life of the software. So the operation of the software and the maintenance of it until it gets decommissioned is really important. The other thing is these words here: systematic, disciplined, quantifiable. So the systematic means here it's not ad hoc, it's not something that you're just making up as you go. And the discipline has the same. I actually think discipline is out of the three words is the least important personally. But quantifiable is important too. And this goes back to that idea of metrics. So systematic and quantifiable means you're doing it in a reproducible way, in a way that somebody can understand, and it has steps involved. There's a process, and you're able to quantify what you're doing, meaning you're able to measure how successful you are, or you're able to measure what you produce, right? And there are different ways to measure. I can measure your success based on the number of lines of code you write. I could say, student A is if student A produces 180 lines of code an hour and student B produces 100 lines of code, you might say, well, student A is a better programmer, right? But that's quantifiable. But then you also need to say, well, what about if student A has 3 times the bugs in their code over student B, and they don't comment? Then you may rethink which one, right? So, but in order to make those determinations and those assessments, and you don't normally assess, by the way, student to student. What you're trying to do is assess the current project status to past projects and so on, just to see that you've improved as an organization. But when you're trying to make those assessments, you need a way to quantify, you need a way to measure so that you can actually decide, have I done something good? If I change my practices and introduce something new, I need some way of seeing, did that actually do anything? Was that a positive? Right? If I don't measure anything, I have no idea. Like, I'm just throwing stuff at the development and not knowing if it's actually helping or hurting. So that's why we need quantifiable. So this idea of systematic and quantifiable in particular, and operation and maintenance being part of development, part of engineering, those are the two things that I really think are what you take away from this. So here's another thing. So step back from software for a second. Let's talk about quality, right? And quality is something that there's a popular view of quality, and there's also what we call a professional view. And quality isn't something where it's a single idea. Like, you don't just look and say, like, I've got an iPhone here. Is this quality? Is an Android phone quality, right? Is my coffee mug that I'm drinking out of, is this a quality mug or not? What defines quality with respect to a mug for you? Somebody might say, well, it's the volume it holds, the fact that it doesn't leak. Yeah, this is a mug, Newfoundland Labrador, by the way. It doesn't break, doesn't leak. I can put in the dishwasher. It keeps my coffee hot. That seems something, right? Nice ergonomic handle. The handle isn't slippery. The surface is smooth when I drink it, so it's not like gonna cut my lips, although that would be a really bad mug, I guess. But anyway, the whole point is that there's all these things we could think of, right? And your criteria and my criteria could be very different. And so therefore, what I think is quality and what you think is quality, another thing we didn't even mention is price point, right? If I told you this mug cost $100, you may be a little bit less inclined to say it's a quality mug for what you get than a mug that does the exact same thing for $10 or $6, right? The fact that it's a mug and not a bowl, sure. So the whole idea is quality isn't a single ideal. There's many aspects, and it really depends. And in everyday life, we usually, think of it as intangible, as something you can judge or feel, not something you measure. It's like, oh yeah, this is quality, I can tell, right? Um, this idea of I know it when I see it. And we often are influenced by perception rather than fact, right? I asked you earlier, because I have an iPhone, is an iPhone higher quality than an Android phone? The best Android phone and the best iPhone that were produced this year, which one's higher quality? Whatever the top one is that you think is Android. Well, people are saying depends. That's opinion. Well, I'm just, a lot of people would say probably iPhone, right? But iPhone actually, they spend a lot more, I would say, of their advertising budget on the notion of quality, right? The sleek design, the position of the buttons, the high resolution screen. Like I think they spend a little more budget on saying they have a quality product, right? Whereas Android, the market is a little bit more, what's the word? It's a little bit more distributed. There's more manufacturers. Some may actually focus more on quality. Some focus more on price point. So it really depends. But you may be influenced by perception by what others around you use. You may be influenced by what you see in commercials, what you see in advertisements on websites you visit. So there's all kinds of things that can influence your view, right? Like, you may think the quality car is based on what your family has always had, right? Like you may say, well, it just depends. So that's just something to keep in mind with popular view. But when we're the right to repair, yeah, Apple, that's another one. Is it repairable, right? What's the cost of repair? How many times does it break down? Those are things that I would factor in quality, right? How long does the battery last? Might be one you care about. Processor, I don't know. There's a whole bunch of stuff. So that's the popular view, though, is this idea of know it when you see it, perception. In reality, when we talk about quality from the software perspective, we're not interested in popular views of quality, right? We're interested in a professional view. And software development is a profession, right? Whether you're a professional engineer, like a software engineer, or you're a computer scientist, there is a profession. And as a professional, you actually have an ethical imperative to produce quality software, to not produce software that's crap. So it's not just about marketing something, or that there's a moral and legal requirement to make sure that the software you create works as expected. Some of that is clear, right? Like if you're writing software for, let's take Airbus or Boeing, right? You want, like, you can tell, like you would have a greater appreciation for the need for quality maybe than if you're actually, writing software like Wordle, right? Even though Wordle's probably used by way more people or played by way more people. Or maybe not more people, though, than ride on planes. I don't know. Okay, there's a good example. So the whole point, though, is that there is a professional responsibility, and this is something you need to think about and care about as a computer scientist. And as a professional, one of the things that you have to do is you have to be able to demonstrate and have confidence that you're using best practices, right? One of the ways you can ensure quality products is by following the best practices. If you do, and if you develop in a way that is considered the ideal way to, you use the practices that people have used who have created some of the best software in the world, you can have you can be more confident that what you produce is of high quality if you're using best practices. So I just want to point that out. And in terms of this professional view, in practical terms, the other thing you want to think about is how do you measure quality, right? So you could think about things, and this is getting back to what we talked about between Android and Apple, whether an iPhone is of higher quality, right? And those are things like conformance to requirements, right? Fitness for use, freedom from errors and failures, customer satisfaction, right? We never talked about it, but are people happy with it? Do people like their phone? If I go to 100 people who have an Android phone and 100 people have an Apple phone, and I say to them, would you recommend that phone? Right? If only 20% of one of those groups said yes, that would be to me a problem, right? So there's these kinds of things that you want to think about. And under that freedom from errors and failures, reliability, right? Will this phone still work in 3 years? Or is this phone going to give out? Right? Those are things you care about when it comes to quality. And you can measure those things. I can measure what percentage of phones still exist, are still being used, right? Still connected to a network in Canada after 3 years. I can measure customer satisfaction by doing a survey, right? I can measure fitness for use by actually doing testing on the devices as an independent third party. All these things I can measure. So if I can measure them then, and I can quantify them, I can then actually compare them and make an assessment. So this is some things to think about with quality. So getting back to software quality, that was just general quality. In terms of software quality, I've got two definitions for you. Let's call them A and B. I should have done a poll for this, but I didn't. So the first definition is the degree to which a system, component, or process meets the specified requirements. B is the degree to which a system, component, or process meets the customer or user needs or expectations. How many of you think, just write in A or B? The first one, A, the second one, B. Which one do you think is the better definition for software quality? I see a both. I see a lot of B's, a couple A's. So I assume the people with B's don't believe in like the Steve Jobs philosophy of, you give people what they, it's not what they want, it's what they need, right? The notion of, Apple under Steve Jobs, there was more of an emphasis on providing them, figuring out what they needed, not actually asking them. Okay, so I see a lot of different things. Anyone want to speak to why they think A is the one? Any volunteers? Yeah, go ahead. Okay, that's a great point. And what about the second one, B? Anyone want to speak to why they chose B? Yep, go ahead. First person with their hand up. Okay. Yeah, so here's I think somebody did say, a couple people said both, and the reality is, and that IEEE, which is the Institute of Electrical Electronics Engineers, which includes software, they actually define software quality as being both. Either of these definitions is appropriate. And if you think about them, there is a large overlap. It's just, it's the perspective you take, right? If you're doing things right, the requirements should actually be based, you should consult with the user on the requirements, right? And ensure that the requirements are what the user needs and expects, right? Whereas on the other case, with user needs, well, the user needs, if you meet the user needs, you're probably largely meeting what the requirements should be. So it's, in some ways it's, but it comes down to sort of, you can meet the requirements in different ways, right? And well, you can meet the requirements and still not meet user needs. Or you can meet user needs while failing to fulfill all the requirements. So there is some subtle differences here. So either of these definitions is reasonable, and either one you could use. But the key here is that both the requirements and the user and what they need are essential to the notion of software quality and measuring software quality. And someone asked here, wouldn't it depend on the scenario where for a client they might have a specific requirement they want the programmer to meet, but if it's a public customer, the software needs to meet their needs? ? So yeah, I mean, this is a tough one, right? Because this is why you can use either too. Like I could be developing, let's say I'm developing a new game aimed at a certain demographic. I may not have ready access to the demographic that I'm developing for, right? Initially. So I may be much more reliant on my requirements because I don't have access to the user base or a significant number of the users. The other thing is that when you have a lot of users or a lot of customers, they may conflict in what they want, right? A particular customer, may want a specific need, but they may be in a big minority, right? So there is this isn't cut and dry. So it does depend on the scenario, I guess, and it does depend on the context. Okay, so that's software quality. And sometimes people define, this is an example of some of the slides I'm not going to cover in detail, but I would encourage you to read through because they are a little bit drier. But basically the idea here is that software quality, sometimes you can actually think about it. There are different models for quality, and I'm only going to give you one here. I can give more if people are interested through Slack. But the idea here is that there are different aspects. Remember I said software quality is not one single idea, it's multiple aspects. Well, with software quality, you can group these aspects of quality into different categories or in a given model different ways. So in one particular model, you can actually group the aspects of quality into technical parameters and user parameters. And technical parameters would include things that are correctness, reliability, capability, maintainability, and so on. So these are things that are open to objective measures and technical solutions. That's more what we focus on in this course. The other side is user quality parameters, things like the usability, the availability, the installability. And these are often subjective analysis, and they often require things like user testing to figure out, or expert analysis by usability experts who may differ in their opinions. These would be much more likely to be covered in a course like in the Human-Computer Interaction, or HCI course, that you may be taking this year or you may be taking in fourth year. Okay. And out of all of these, there's a whole list of technical parameters. Correctness is one of them. Reliability and so on. These are the ones you can read through on your own. I've also included some measures here. But one of the things I wanted to touch on that I will spend just a couple slides on is this notion of correctness, right? We haven't mentioned the word bugs yet, but software bugs dominate what you hear about software quality. If it makes the news and it's about software quality, it's probably about a bug, right? It's probably about some bug that's been found and could be exploited, security bug, some bug that caused something to crash. So we've seen this in the aviation industry. We see this in the autonomous vehicle industry, right? So bugs and defects, they are things that are inevitable. Every software system has them. The question is, how many do they have, and what's the likelihood of them actually occurring? And a lot of what quality is with testing of that is identifying these bugs and trying to mitigate their impact. So with that in mind, why do people care about bugs? Why are we interested in bugs? Well, More bugs means usually lower quality. Yeah, so you do all of these other things. You do all these practices and processes to ensure you produce high quality software, which implies you're trying to produce software without bugs. But in reality, the software will still have some bugs in it. So then you go back and triage by using techniques like testing to try to find the bugs that still exist and get rid of them. And you want to do that so that your software doesn't fail, it doesn't crash, it doesn't behave in a way that the user will is unexpected for the user. So here's one example, and I probably should have I could have used another example. Maybe I'll bring in a couple other examples another day. But one of these, this is just one of the most widespread ones, is this heartbleed bug. It happened about 5 years ago. Do you guys remember this? So heartbleed is a security bug. I like to include this example because you can actually go and look at the details if you're really interested. Log4j is another one. I probably should have just updated this to be Log4j. This is another example of Log4j is software that's used for logging on a lot of hardware that's used in the network, such as routers, switches, that kind of stuff. Had huge impacts, caused a whole bunch of our government as well as industry sites to be temporarily taken offline. And basically it was the Log4j was a bug that caused an exploit which allowed somebody to gain access to the system, a security bug. And in Heartbleed, it was a similar thing. It was a security bug, not a design error, which means it wasn't like somebody overlooked something in design. It was simply that there was a coding error. Somebody made a mistake when they programmed. In this cryptography library, OpenSSL, and OpenSSL is what we use for secure communication on the internet, one of the main libraries. And all it did was the problem was they didn't validate the input in a given point in the library. And what it meant is that the buffer could overread, meaning the buffer could read beyond where it was supposed to, which means it could actually read malicious code, which could then allow somebody to circumvent the security and access, either cause damage by deleting data, or provide them, in some cases, even access to a system. So these types of bugs do happen, and in the case of both Log4j and the OpenSSL one, I like these examples because they're open source. These are open source libraries that are available, so you can go on like GitHub and see the source code. You can actually go and see what the error was if you're interested. Just because these are open source doesn't mean all are open source. There's lots of these types of bugs that happen in closed source systems too, but the open source systems are nice because it allows you to kind of look under the hood if you want to see it. And we'll talk about the value later of quality. What's the impact on quality of an open source development model versus a closed source? And there's a lot of emphasis, especially in the closed source community, on finding bugs like this through things like bug bounties and bug hunting, which we can also talk about later. So this is one example of a bug that can happen. And the key here is this, and this is actually, there's deliberately no, this is actually a graph from, it's a little bit of an older one, but it actually shows you a little bit. And it's a rough numbers, but the idea here is you look here, and what you see in this is if you go to the far side, you see, oops, I guess my finger gets cut off. You go to the far side, the blue, you'll see each phase of development, from when you have your source code to unit testing, which is when the developer tests their local piece of code they're working on, function tests, system tests, and after release. So it's the different types of testing you do up and through putting the software in operation. And what you notice here is the percentage of defects that are introduced. Where are most of the defects introduced? Where are most of the bugs introduced? This is, remember, coding bugs here we're talking about. There could be design bugs in that, but when we have a case like here where it says it was a coding error, where are most of the bugs introduced? if you look at it, it's actually in the coding, right? 85% of the bugs are introduced in coding. A lot less of them are introduced when you're doing testing, meaning when you find a bug, you add a new feature, and you end up changing the code in some way and introduce. So the majority happen in coding. But what do you notice with the yellow line? What percentage of bugs are typically found when you code? Almost none, right? When do you find bugs? Well, in unit testing you find some, in function testing you find more, system testing you find more, and after release you typically find less. Okay? And if you think about this as this, which is interesting, so you find more bugs in system testing than in unit testing. And then the thing to think about is this. See that purple line? That tells you how much it costs. So if you find your bug while you're coding and just fix it on the spot, it might take $25, right? That's like, you know, let's say your salary works out to, I don't know, let's say it was $200 an hour and you spent, you know, a few minutes on it, $25, right? If it's unit testing, well, you've also got to factor in the cost of creating unit tests and so on, and then finding the bug, seeing the bug, finding where it is in the code, because you now have to locate it within the unit, and then you have to fix it and you have to test it, $100. Then you get into function testing. You know, you're now testing a little bit larger scale, 250. System testing goes up to 1,000. Why does system testing go up so much more? It's because it's the needle in the haystack issue, really. You have as much, when you're dealing with unit testing, you're only testing a function or a class. You have a much less code to look through to find a bug. When you get to the system level and you find a bug, you have to find the bug in the entire code base of the software. So it's much harder to find it. So it takes a lot longer to locate the bug. Even when you know it's occurring, you still have to find it. So the key here is why we care about bugs is simply this. The longer they last in your system, the more expensive they are. And they're created early. So if we can find them earlier, it's cheaper. And then the last one, after release, it says 16,000 here. And remember, these are a little bit arbitrary because it's not but it's representative. The key here is after release, if a bug happens, right? Think about how expensive it is. And I'll just use the example of Log4j or Heartbleed as an example. If they had found that bug in unit testing, it would have been cheap. If they had found it in function or system testing, it would have been cheap. After release, when it's deployed in hardware, separate hardware systems all over the world, where they can't just go and do a patch, where everybody has to patch it manually, think about how much that cost. In Heartbleed, I bet it's way more than this. It's way more than 16, or in Log4j. Like, it probably costs millions of dollars, easy. Well, no, it's not quite that, but the point is that you want to be thoughtful about what you're doing early on. So if you don't use quality practices, you're basically just pushing it down the road to find later. So if you're not using good quality assurance techniques and you're not finding bugs sooner, you're finding them eventually. And the eventually is after release when the customer finds them. And that's bad. So you want to actually do things earlier to find them earlier because it's cheaper. Yeah, exactly. So that's a little bit about bugs. We're almost out of time here. So the other category is the user quality. I'm not going to touch these today. I'm not even going to get through all these slides. That's okay. I'll just cover these last ones next time. But I'll just tell you briefly. I'd ask you, actually, what I'll ask you to do is read through these and I'll cover the key points. We're going to talk now about quality assurance. How do we achieve quality? And I'm going to talk about 3 principles of quality. And these are super important. And it's know what you're doing. Understand what you're actually doing in terms of development. Understand what you should be doing. Meaning understand what your goal is. Right? and know how to measure the difference, right? And I've got each of those in detail, and I'd encourage you to read through each of these principles in detail. And the last thing I want to mention as well is, in addition to following these principles, there's also a whole industry around ensuring you actually do have good quality practices in place. And this is the standards and maturity models. So things like ISO standards. So there's actually a particular ISO standard, which I've listed here: ISO, IEC, IEEE 90003. 2018 is the year. They update it every 5 years, I believe, or every 4 years. That's actually the guidelines for applying ISO 9001 to software. And they will come in and certify you to say that your practices meet this certification, which is certifying that you are following good practices. And that's something that also happens as well, and we'll talk about that later in the course. Okay, so what we've covered today is an intro to the course. We've learned what software engineering is. We've learned what quality is and how it applies to software. Next time, we're going to actually jump in and start talking about agile development in particular as a form of software process. And we're going to pepper into that some examples from industry. Probably we'll talk about Spotify as well next class on Thursday. Thank you all for your time. I really do appreciate it. Hope you get a lot out of the course, and looking forward to working through this with you. There's no readings right now, but whenever there are readings or videos required to watch, you can actually go and see that on the website. The only readings I'd encourage you to do is read through all these slides so that you can read through the ones that I didn't cover in detail. Okay, take care everyone. See you on Thursday.